Hi everyone, I am Mahesh. In this video, I am going to show you how to search for an element in a given array using binary search algorithm. And the first prerequisite to start for binary search algorithm is the elements in an array should be in sorted order. And now let's take an example. Here is an example where we have 10 elements in an array and you can clearly see all the elements are in sorted order. And binary search algorithm mainly works based on indexes of the array elements. And you can see here the first element is denoted with the 0th index, and as there are 10 elements in the array, last index is denoted with 9th index. And in this example, we are going to search for the element 30. And how to search and how to start the binary search algorithm is, we'll take two variables, one as low and another is high. So low is pointing to the 0th index and high pointing to the last index in the array, that is 9 in this case. And then we'll calculate as a process, we'll calculate mid value, that is average of low and high. In this case it is 0 plus 9 by 2, that is 9 by 2, 4 point something. We'll take the floor value 4. And you can see here, then what we'll do is we'll verify if the search element which we wanted to find is equal to the value pointed by the mid. What mid is pointing to? All low, mid, high, all are denoting the indexes here. We need to remember that, not the actual elements in the array, but they are actually denoting the indexes in the array. And we can see here, so mid value is 4 now, and we wanted to check the value which is present in pointing to mid. So it is pointing to 4th index and the value in it is 50. Is search element 30 is equal to 50? No. Is search element less than or greater than the current element? So it is less than 50. In that case, what we need to do is, so we can conclude that the element which we are trying to find in the array can't be at the right side of the current value pointed by the mid, and it can only be on the left hand side as the elements in the array are in sorted order. So what we are going to do here now is, we'll make high value mid minus 1. As we already verified the element with the mid value, it is not equal and it is less. So we are actually modifying high value to mid minus 1. So 4 minus 1, 3. Now high becomes 3. High is pointing to the third index. Then we'll continue the process of evaluating the mid value. Mid value is like low plus high by 2. And in this case, it is 0 plus 3 by 2. And we'll take the floor value. So it is 1. Mid should be pointing to 1 now. Once we evaluate the mid value, then we'll actually compare the value which is pointing by the mid index. Mid index is 1 now, and the element in it is 20. So we'll compare search element 30 with 20. Is 30 equal to 20? No. Is 30 less than or greater than 30? 20. So 30 is greater than 20. So in this case, our whatever element we are trying to search for can't be on to the left hand side of the mid. It can only be on to the right hand side. So for that, what we'll do is, this time we'll actually modify low value to the mid plus 1. We'll bring low to mid plus 1 value. So it is 1 plus 1, 2. Now low will point it to the second index. Now we will again continue the process of calculating the mid value, that is 2 plus 3 by 2 now. So this becomes 5 by 2 and we'll take the floor value. So it is 2 now, and mid value is 2 now. Once we evaluate the mid, what we'll do, we will actually compare the search element with the value which is present in the index pointed by the mid. So it is 2. What is the value at second index? It is 30. So our search element is also 30. Is 30 equal to 30? True. Then we can conclude that element is found at the location pointed by the mid variable. So that is how we are going to find the element. And when do we stop this process? So if you observe here, in each iteration, low and high are like coming close to each other. And so once low either exceeds low exceeds high, or high is less than low. So if low is greater than high or high is less than low, then in that case what happens, all the elements in the array are traversed and we can say that the element is not found. This is how we are going to, this is how binary search algorithm works. And now let us apply this same in by writing a Java program. Let me create a new class and we'll name it as binary search. We'll declare an array, integer array a, and we'll take the same elements as shown in the example, the same 10 elements in the same order. Then what did we do? We took an element to search for. So let me call that as search element. Let's actually verify for 30. And then we need two variables, one pointing to low and another pointing to high. First of all, we'll take low pointing to the first index and high is pointing to the last index in the array. And how do we get the last index in the array? Let's take the length of the array, and length becomes 10 here. Array length is 10, but the last index is 9. So we'll minus 1 from the length. That becomes the high value. Then what we'll do is we'll write a loop here and we'll come back to this condition later. First, let's calculate mid value. Mid value is low plus high by 2. Fine. Now what do we need to do? Once we calculate mid, we'll actually verify if our search element is equal to the element pointed to by the mid index, that is a of mid, as mid is pointing to the index a of mid. We'll verify that, and then if it is equal, then we can just say element found at index. We also know the index, that is index is pointed by mid. And then we don't want it to continue the loop. We can break the loop as we already found the element. Now what if if it is not equals, then we'll actually check another condition of if either search element is it greater than mid. We'll verify. If it is greater than mid, then we'll go back. So if you see here, in our case, first it was pointed by 0, 9, then high becomes 3. So mid minus 1, 3. So in our case, it was lesser than the value 50. So we decreased high value. We actually calculated high value to be mid minus 1. So what we'll do here is we'll write the same condition, like my search element is lesser than a of mid. So in that case, what we'll do is we'll calculate high value to be mid minus 1. And it can either be equals to, less than, or greater than. So we can write else part here and can say low equal to mid plus 1. If the search element is greater than a of mid, then we should be pointing our low to the mid plus 1, and we'll only search at the right hand side of the current index. So that's the reason we are bringing low to the next value of mid. And this process, we are almost done with the program, and you can see here this process we wanted to continue till our low is less than or equal to high. Why equals is, say for example, in some case it can be low, mid, or and high, all can be at pointing to the same index. Like say for example, we have an array of one element. So in that case, definitely low will be 0, high will be length minus 1. So it will be low, high also will be 0. So in that case also algorithm should work, and if we actually search for the same element, it should say the element is found at the first index. So even at that case also should be satisfied. For that we are writing low greater than or equal to high. That is our condition. Now we are done. Now what if if the element is not found? So that we need to actually handle. If we directly say that display here element not found, what happens is it will actually, even though if element is found, fine, it will just display this and then comes out of the loop, and before exiting the program it will also say element not found. We don't want this to be displayed when element is actually found. So sorry, so what should we do? We should be having a condition here which actually should say us that the element is not found. For that, if you observe here, we can actually see here, if the loop is break by this keyword break, then when will this happen? If you observe, when this condition is true. And when will this condition be true? When the while condition is true, then it enters into the loop. Then if it calculates mid value, then if condition is verified, only then it will, if this condition is satisfied, it will enter into the if condition, and then break is actually applied, and then it will come out of the loop. Meaning if this break is when we exit the loop because of this break keyword, then still this condition will be true. And when will this be false? So when you when the actual loop exits because of the failed condition of this while loop. And what's the failed condition of while loop? We'll write that now. If low is greater than high, this we discussed. When low exceeds high, then we, meaning like we traverse all the elements in the array and we didn't find the element, and only in that case we wanted to display that element is not found. So that's that condition we are actually using it here. Now let us verify the program, and we can see here clearly it says element is found at index 230. Now let us search for some non-existent value. So this element doesn't exist in the array, and we can clearly see it displays element not found. And we can also search for last element in the array like that, and it says element found at index 9. So this is how we can actually search for an element if it exists or not in a given array using binary search algorithm. That's all for this video. Thanks for watching.